Okay, so I thought the last one was going to be the last video, but we do have one more. This is another just examples. I really want to make sure that you guys get this because we use combining like terms all year long. It is something that you've got to get comfortable and familiar with. So I want to make sure that we get this. So down here, we've got another example. So we have, let's start with the k squareds. Okay, I'm going to combine those two, okay, because they are both k squareds. Then I have the k's, this negative k and this negative 5k, and they can be combined. And then I have this 7. Well, 7 doesn't have anything else to combine with it, okay? So it'll just stay as it is and be brought down. So 8k and negative 2, if I add 8 and negative 2, I get 6k squared. Okay, remember again, we're adding and subtracting, so this k squared stays k squared. We do not change the exponent. Then we have a negative k and a negative 5. If I have negative 1 and I add negative 5 to it, I get negative 6. And again, that k stays, okay? And then the plus 7, all right, has nothing to add to it. There are no other constant terms to add, so I just bring it down as part of my final answer. Now the k squared cannot be combined with the k cannot be combined with the 7 cannot be combined with the k squared. This is as simple as it gets. Alright, another example similar to that. Let's start looking here. This has a variable term, or a variable of a squared b. A squared b is the entirety of that variable term. It cannot be separated with what we're talking about today. You're going to leave it as a whole. And so in order for this to be something I can combine with it, it also has to be exactly a squared b as the variable. Okay, since it is a squared b and this is also a squared b, I can combine these coefficients together. And then the last thing that I have here is again this 7 that doesn't have anything to combine with it. So if I have negative 4 of these a squared b's and I have 10 of these and I add them together, negative 4 and a positive 10 is 6. And again, that variable term, a squared b, stays the same, a squared b. And then we just bring down that plus 7 because that plus 7 is the constant and there's nothing else to combine it with. I cannot combine the 7 with this because the 7 does not have an a squared b, and the a squared b has to have another a squared b to combine it to. Okay. Alright, a couple more examples. I'm going to flip my page real fast. Alright, so here we have x squared, so let's look for other x squareds. I'm going to use blue to represent that. And if I look further, that's an xy, it's not the same. That's an xy, it's not the same. That's a y squared, it's also not the same. So there's only one x squared. So it won't be adding to anything, we'll just bring it down. Okay, then we look at the 2xy. Okay, and I'm looking for anything else with the variable xy. This negative 7 also has an xy, so those two things can be added together. And then over here is a y squared. It is not the same as xy. So then the last thing that I have here is a y squared, and there is nothing else to add it to, so it will also just be brought down. So if I go to combine these, x squared, it's brought down. 2 combined with negative 7 is negative 5. Keep that variable of xy. And then we can bring down the 4y squared. Okay? None of these can be combined any further because they are all different. So that's our final answer. Very similar is the next problem. We have an a squared. There are no other a squareds, so nothing to combine that with. There is an ab and a negative ab over here, so those can be combined together. And then finally there is a b squared, nothing else to combine that with. So a squared, and I combine a 7 and a negative 10, and I get negative 3, and then I bring down the b squared. Again, cannot be combined any further, so we leave it as it is. Okay, next one. We're going to have to be very careful to look at this one. So we start off with an a squared, b squared. So I am looking for anything else that is an a squared, b squared that I can combine to that. This is ab squared. It is not the same as this because this has a power of 2 on the a. This does not, so it cannot be combined. So keep looking. Here we have a squared b squared. So I can combine that negative a squared b squared with this right here. Okay, so let's look now at this ab squared. This is also an ab squared, so it can be combined together. So I have the 2 orange and the 2 blue that can be combined. So if we combine the blues, 6 and negative 1 is 5, and then again we keep those exponents, everything stays the same, a squared b squared, and then we have a 3 and a negative 4. 3 plus negative 4 brings me to a negative 1, and remember, if it's a negative 1, we generally just leave the 1 off of the coefficient. So we're just going to do negative ab squared, okay, with the understanding that there is a 1 right here. All right, those can't be combined, so that is our final answer. Okay, one more example, just like these others. All right, so we have x squared y. We're going to keep looking for another x squared y. This is xy squared, so that's not the same. Also xy squared, not the same. But here is another x squared y. So those can be combined. And then here we had that xy squared and this xy squared, and they can be combined. So when we combine these, 19 and negative 16 is 3, and that variable, it's x squared y, so that's what I'm going to bring down. And then I have a negative 4 and a positive 5, which adds together to equal 1. And again, that same thing, that 1 is understood to be there, so I'm just going to bring down the x y squared. And those are not the same terms, so we cannot add them any further. We leave it as 3x squared y plus xy squared. Okay? All right, one last question, and this is just kind of using what we know. So we're talking about perimeter. Remember that perimeter is the distance around the outside of a shape. All right, and so we find it by adding all the sides together. So a rectangle has 4 sides, so it would be side 1 plus side 2 plus side 3 plus side 4. Okay, that's how we would find the perimeter. Okay, remember that a rectangle has 90-degree angles. Okay, it also has 2 long sides that are the same length. So if this length is 7x plus 1, then this length must be 7x plus 1. And if this length, the other 2 sides are also the same length. So if this is x minus 3, then this must also be x minus 3. Okay, so even though they didn't give us all 4 sides, based on what we know about a rectangle, we know that all 4 sides are, that the 2 opposite sides are equal, and then the other 2 opposite sides are also equal to each other. So asking to find the perimeter, we know now the length of each of these in variable terms. So I can add these together. We'll call this side 1, 2, 3, and 4. So perimeter is going to be the first side, 7x plus 1, plus the second side, x minus 3, plus the third side, 7x plus 1, plus the fourth side, x minus 3. Okay, and so might help to have those in parentheses. Okay, you can do it that way. You can go back to using your figures, okay, and draw them out. You can also use your colors to do this, okay? It does not matter to me. I'm going to use the colors because that's how my mind works. So I have 7x that I'm adding to x, that I'm adding to 7x, that I'm adding to x. So 7 plus x plus 7 plus x. That's 7, 8. 8 and 7 is 15, and 1 is 16. So there are 16 x's. All right, and then we have these constants, 1, negative 3, 1, and negative 3. So 1 minus 3 is negative 2, plus 1 is negative 1, minus 3 is negative 4. So we end up with a total of negative 4. Okay, so the entire perimeter of this rectangle is 16x minus 4. which doesn't really help us if we're looking for an actual measurement because we still have an unknown of x. We don't know what x is. If we knew what x was, we could substitute it, which is the evaluating expressions that we're also talking about this week. We could substitute that number for x, plug it in, is what that means, and we could solve to find out what the parameter is. But as it is, this is as far as we can get this. We can't simplify any further, we can't go any further because this is as simple as it can get. This is an x term, this is a constant term, and they cannot be combined any further. Alright, so hopefully these videos help. Let me know if you have any questions. I'll be glad to answer anything that you need me to.